Hello, welcome back to Cracking the Cryptic, turning out 2 videos a day, every day. And this is my video today. It's going to be a puzzle called Papier-Mâché by Blundell, who has featured on the channel, I think, before, but not for some time. And, well, it's an indexing puzzle, and I hear groans from 2 sorts of people, which constitutes most of you between them. One sort tries the puzzles themselves and often finds indexing pretty difficult to follow. And the other watches me solve puzzles and knows that I'm appalling at indexing puzzles and understanding how the indexing works. Which, intriguingly, I mean, all the evidence suggests computer programmers have no trouble with indexing. And congratulations to those of you who do that for a living or a major hobby and find indexing really straightforward, but I find it difficult. I've read the rules through once and I find even reading the rules quite difficult here. So we'll do that in a moment. Now, coming up on the 1st of July, recently released by DreamWorks is the film Ruby Gillman Teenage Kraken. And we are launching Kraken the Cryptic, a set of puzzles themed on, well, on the movie, frankly. And there's 6 puzzles, a little meta to hold them together, and we think you're going to enjoy them. Quite similar standard to last month, maybe a tiny bit easier, not sure about that. I don't think there's quite a Saturnalia equivalent this time, but we're looking forward to bringing that to you. There's certainly no By Jove equivalent, so don't worry about that. That will be out on the 1st of the month. It's being checked at the moment, so good news there. And we'll certainly bring something to you on the 1st of the month. It's almost certainly that. Looking forward to that. Do join us on Patreon for other content. We've put up the first of the solution videos to last month's The Planet Suite, and that's on Patreon for the $3 Patreons who get that service for that tiny bit of extra money. Thank you. Now, for a little more extra money, you can get our apps, and we have domino apps, and we don't have indexing apps. No, not yet. But there's various types of apps, classics and, pardon me, Killer Sudoku and Arrow and Thermo. A lot of the types that will be represented in the Kraken the Cryptic puzzles. In fact, I've now got hiccups. I don't know how this has happened. This is not going to help, so I may have to restart the video in a second. Let's see if that does anything for them. Okay, I haven't had one for nearly 30 seconds, so that's good. Right, also on the links under the video, you can check Sven's Sudoku Pad out and the Discord server, the catalogue of our puzzles, our merchandise. But the first link is to this puzzle, Papier-Mâché by Blundell. And normal Sudoku rules apply, so we're going to be putting 1 to 9 in every row, column, and every 3x3 box. Digits joined by a black dot must have a ratio of 1 to 2, so you could put a 1-2 in there, or an 8-4 perhaps. Now, here we go with the indexing. If a green cell, row R, column C, has a value V, then the cell row V column C has the value R. Now, there is an example which is handy because I think we're going to need it. For example, if in row 3 column 5, this is a green cell here, if there's a 6 there, then in row 6 column 5, there's a 3. Okay, so it's passing numbers down the column. This is in row 3, so if there's a 6 there, you put the 3 from row 3 into column 6. Into row 6 in the same column. So I guess that 3, if this was on a green cell, it would be doing the exact opposite. It would be saying that there was a 6 there in row 3. So it's indexing up and down the puzzle only, these green cells, which is intriguing. All the green cells, I was going to say it's a coincidence that all the green cells have a black dot on them. I'm sure it's absolutely not a coincidence, but the greenness and the black dotness are 2 different things. Blundell did point out in his original instructions, or hers, that there's no negative constraints, but I don't think that needs saying. It would be stated if it did apply, and it's not. So do give it a go. Intriguing indexing. I'm terrified of this, but I'm nonetheless going to restart my clock and say, let's get cracking. And what are we going to do? I mean, we've got a very generous given 5, but we've only got these black dot green cells to go on. Okay, well, at the risk of inviting massive scorn from Simon, I'm pencil marking these with all the possible black dot digits. And I'm looking at row 3. Row 3, I'm looking at you. So why? Because I just want to work out what's going on. So if this was a 1, that would be saying that in row 1 in this column, there is a 3. Because we're in row 3, every time I look at any of these cells and think about what their number means, I'm thinking about placing a 3 to represent row 3 somewhere else in the same column. So in this column, well, in fact, this digit is going to say specifically that there is a 3 in one of those, oh no, I've got it wrong, one of those 6 rows in this column. Oh, my goodness, if we had a 6-some going across the grid, which we don't, we'd have a kind of 6-finned swordfish. I don't know what that sort of fish would be with 6. Anyway, never mind about that. What this is saying is, if this was a 1, let's just imagine that. That's saying there's a 3 there. Oh, 3 in the corner. I don't deserve that little party celebration on a speculative just explanation move. Now, this wouldn't work. That's interesting. We've got an entropy consideration. And I'll just show you why that wouldn't work before I take it out. If this was a 1, that would have to be a 2. And that's saying, it's still in row 3, that's saying there has to be a 3 here. And now we've got an impossible clash. Now, why I'm calling this entropy is because of an entropic lines rule that we sometimes have, which requires digits to be either from 1, 2, 3, 4, 5, 6, or 7, 8, 9. They have to alternate in some form in entropic lines. But this is quite important. It means we can't put 1 and 2 here, because they're from the same entropy set, because they would put 2 3s here. Exactly the same would happen if we put 2 there and 1 there. So all of these numbers are not right. And that means we don't have a 1 in this set. We could still have a 2 if this was a 2, 4 black dot. But I think it must mean the same here. There's no 1 in this set. Am I right? Yes, because that would put 3 either there and there or there and there if we had a 1, 2 pair here. So that's something learnt, and entropy has entered the indexing puzzle. I suppose it is always... The classic 159 indexing puzzle has a lot of entropy in it, so I shouldn't be surprised, but I am, because I wasn't expecting it. Right, one of these is a 3-6 pair, and the other has a 4 in it now. Because we can't make up one of these black dots with... Well, sorry, we can't make them both up with just the numbers 2, 4, 8. Then 3 and 6 must get involved, and they have each other as necessary counterparts on a black dot. So one of them is a 3, 6 black dot, and the other has a 4 in it. So this digit is now not 3, 4, or 6. That is 1, 2, or 8. It is from the 1, 2, 4, 8 family, because they always must go together. Digits from 1, 2, 4, 8 on black dots, or digits from 3, 6. Now, what does a 6... A 3 is actually very... It's much less helpful than anything else, because it's a self-referential digit in this row. If we do put a 3 in one of these cells, as we're going to have to, that 3 is not telling us anything about any other cell in the grid. It's saying in row 3 in this column, there's a 3, which we already know. So... The 3 is no help, but the 6 might be. The 6 is going to put a 3 for row 3 somewhere down here. One of these is going to be a 3. Wherever 6 appears here, there's going to be a 3 down here. Now, that can't be here, because that would need a 6 here. Then you'd have a 3, 6 pair here, but we were postulating a 6 there to get the 3 here. So that's not a 6. That's going to happen down this final column as well. If that was a 6, we get a 3 there and a clashing 6 here because of the black dot. So 6 is in one of these cells in this row. If it's here, we get a 3 there. Then we get a 6. Yeah, this doesn't work for exactly the same reason. I just hadn't worked it out. but I am concerned that it doesn't work the other side as well, and I've reached an impossibility. Let me just work this out. What I'm claiming is that if you put 6 in this cell, let's just do it in full, that is saying that in this column, row 6 has a 3, because this is in row 3. Then that requires a 6 here and a 3 here. But we also need a 3 here on this black dot, and now we've got a clash, and it's impossible with those 2 3s. So that can't happen. So I think I've ruled out 6 from both of those cells. And I think this has to be a 6, but I think we're going to find the same problem. Oh, maybe we're not, because they're not all joined up by black dots. They're all green. Right, that 6, which I think we've deduced now, it means there's a 3 there, which is self-referential and not telling us anything. But it also means that there's a 3 here. That's what the indexing is doing. This is saying in this column, there's a 6. There's a 3 in row 6. So that's a 3. Then we get a 6 here. Now that does seem to fit. Now we don't have a 3 over here. In fact, everything else in this row is from the 1, 2, 4, 8 family. So these 2 are as well. This must have a 4 in it. Okay, so let's just do a bit of Sudoku first. We're going to get a 3 into one of those cells, a 6 into one of those. That was precious little Sudoku, wasn't it? Now, there is definitely a 4 in this pair. It's either 2, 4 or 4, 8. And that 4 will be saying put a 3 in row 4 in one of these cells. The other cell here is saying put a 3 in either row 2 or row 8. Oh, hang on, what's... Oh, this 6 is self-referential. Oh, that's annoying. I had realised I hadn't worked out what the message from these indexing numbers was. But unfortunately, it doesn't advance me at all. That 3 is saying, because we're in row 6 now, it's saying put a 6 in row 3. We'd already done that. And that 6 is saying put a 6 in row 6. And that itself we have already done as well. Okay, let's think about... I didn't get very far there in the end. Do we think about these or about this? I haven't thought about this much. This is saying where to put a 3 in this column. It's either in row 1, row 2, which it can't be, or row 8. Right, it can't be a 2. So that is 1 or 8. This is now 2 or 4 on the black dot. Am I right? It can't... Yeah, that was saying put a 3 there. So this is saying, well, there is a 3 in one of those 2 places in this column. This is saying either put a 2 in row 2, self-referentially, or put a 2 in row 4. So the 2 in this column is in one of those 2 places. And I don't think that's helping me much. So I'm going to have to think about these now. This is talking about 6s. Right. This can't be a 4, because that would say put a 6 here, and there's already a 6 in this box. Oh, it can't be a 1 or a 2 either. We need a different entropy. That has to be an 8. Yes. Because 1, 2, 4, and 8 are saying put 6 somewhere here. And there's only one place it's allowed out of those. It's there. That makes this an 8 as an indexer. That makes this a 4, and that says put a 7. Remember, this 4 is in row 7 into row 4. I'm getting along okay with this now. Now, there's no 8 here. This is either a 1-2 pair or a 2-4 pair. But I think for exactly the same reasons as this, it can't be a 1-2 pair. We'd have an entropy problem with 2 6s going up here. So that is a 2-4 pair. And it's saying put a 6 in row 4 and put a 6 in row 2. This could still be any of these digits, but it's saying put a 7 in row 1, 2, 4 or 8. Well, it can't be a 4 then, because that is now 3 or 6. Oh, I could have eliminated that 4 just by looking across the grid if I'd been a little bit sharper. Now, what was the other digit? Was a 2 or an 8 saying put a 3 either there, which would give us a deadly pattern, still possible, or a 3 down here, which would clash. I don't know. I can't see how That clash is resolved. Let's just keep going. Let's go on this row. Ah, we've got a 6 in the row. Lovely. So these can't be 6, 3 black dots. These are a 1, 2, 4, 8 family. Ooh, interesting. What's that going to do for us? That is going to... How can we have a 1, 2? Oh, because the boxes are separate. Yes, okay. One of these is a 1, 2 pair. And that's going to be put... All right, let's think. This is row 8. So these are these green index boxes are deciding where are we going to put 8s in these columns. And they're going to go into row 1, 2, 4, or 8. So in that column, there's an 8 in one of those. This is going to give us a jellyfish, which is a term for a kind of 4-way... Ooh, hang on. Right, this can't be a 2 because we've got a given digit there that can't be an 8. Yeah, these are always placing 8s. So 8s in these rows and columns are confined to these, well, it was 16 cells, it's now 15. Actually, this can't be a 4 because of ordinary Sudoku considerations, so that is not possible to be an 8 in this column. That being 1 or 8 means this is 2 or 4. And that means 8 is necessarily in one of those two, not in those cells. So one of these is an 8. Ah, hang on. We've got to have an 8. Only one of those can be an 8. Maximum. Therefore, one of these must be an 8 in columns 4 and 6. And once one of those is definitely an 8, this cell isn't, because it's in the same box. So there we go. We got a 1 there and a 2 there. The 2 is self-referential, but the 1 gives us a 3 up here. That stops this being a 3. Now, where's 3 in this row? That's nice. It's not here and it's not here by Sudoku. It's not here by pencil marking, so it's in one of these cells. And it's forming an X-wing with 3 there. That's using up the 3s in columns 1 and 2. And the 3 in column 3 now has to be in this box, and there's only one place left for it. That's removed 8 as a possibility from row 2, so that can't be a 2. Now, what I have to remember is that one of these is definitely a 1-2 pair, and the other is a 4-8 pair. Now, didn't one of these... Yeah, only one of these can be an 8, because they're all in the same box. So one of these two has to be an 8. So one of these is a 4, and that's not a 4 now. That is 1 or 8 too. This is 2 or 4. That can't be 8. So this is a little X-wing of 8s that's created by the indexing down here. And the other X-wing of 8s is in those cells, so that can't be an 8. And I still don't know how they resolve, but I feel like we've got an awful lot closer. What about this baby? It can't have a 3 there. Oh, it can't have a 3 in it at all because we've fixed 3 in this box now by fixing 3 in the row. So again, this is from the 1, 2, 4, 8 family, but these cells are placing 9s. So it's not quite as all-encompassing a mix. We're looking at placing 9s in some of those cells, but some of them are ruled out. So 4 is ruled out there. 2 and 8 are ruled out here. Ah, this is 1 or 4 now. This cannot be 1 anymore. It is 2 or 8. So 9 in this column is in one of those. 9 in this column is in one of those. Oh, again, it can't be 2, 1. Why can't I learn this? Because that would put both of those 9s in. So this one is 8, 4, and I think we're away now. 8 there, 4 there. That's placing the 9s. Look, that's fixed this 3 and the X-wing on 3s, and that's fixed 6 and the X-wing on 6s. And we need another 6 in the columns, and we've got all the 3s. We need another 9 somewhere up there. Most of our indexing is done now. We've still got to resolve these patterns of 8s, and we've got these. And we've got a 6 there, so this is a 2. Sorry, I should be in the right mode. Now that 4 says there's a 6 here, which we've already got. This connects to either a 2 or an 8, which is putting a 7 either there or there. Well, we know where that is. It's got to be here. That's a 2. This, actually, we know what that is from that. Okay, 1, 2, 4, 8. Let's fill in the 8s accordingly. Oh, one of them is a correction to a 6 I accidentally wrote in there. But that's it. We've done all the indexing. Oh, well, I've still got those to do. I've found that I get a 9 in this corner, not the 3 I speculatively tried to put in earlier. Oh, we're not going to get a 3 in the corner today. Now, there can't be 8 in those by Sudoku. There are 2 and a 4. They're placing 3s. Oh, well, there. So that's a 4. But this hasn't worked. Something has gone wrong. Oh no, what have I got wrong? I've got something wrong here because now I want... Well, now I want to put an 8 here. And I've got an 8 here. Oh, bother. Was it only when I disambiguated those I got that 8? Just couldn't go in 2 or 4. This can't be an 8. It's a 1, and that puts an 8 up here. This is a 2, and we get an 8 here. This is a 4, and that's an 8. And yet, that makes this a 2-4 pair, which is talking about where to put 3s. Oh no! Well, at the moment, I mean... Okay, maybe I was previous with the bottom row. Maybe that doesn't have to be an 8-4 pair. 2-1 doesn't work. Okay, why had I restricted it down to these possibilities? This is to place 9 in somewhere in 1, 2, 4 or 8. 1, 2, 4 or 8. And I'd said this has to be 1 or 4 because 9 can't be in 2 or 8. I think that's right. And if that's 1 or 4, this is 2 or 8. Then I decided it couldn't be a 9 there, but that was after I'd placed 6 there. So, have I gone wrong before this? I probably have. This is painful. I was happy with that 3 deduction, and I wanted a 6 from this 2-4 pair. Yes, 6 is there. That's all right. Now, I need to be more careful with this. This is saying there's a 1 or a 4. Sorry, this is saying in row 1 or 4 there's a 9 in one of those 2 cells. Oops. This is saying there's a 9 in 2 or 8. But then I decided that the 9s couldn't be in 1 and 2. Ah, it doesn't have to be a 1, 2 or a 4, 8 pair. That's in this row where it has to be a 1, 2 or a 4, 8 pair. This can be a 4, 2 pair. Right, that's not a 1. That is a 4. But that doesn't decide what this is. It does decide there's a 9 there. Now, okay, that's where I went wrong. In fact, I could have known that was a 4 from a 4 X-wing from there. But I then made this an 8, and that went wrong. So that's going to be useful to me in solving the puzzle now. Those of you who say that I make lucky errors, sometimes I make errors that aren't so lucky. Right, 8 is in one of those 2 cells in this column. These are from 157. I should really think about where 6 is going. No, I don't know yet. Do I know where 3 is going? Right, there is no 3 going into row 2 above those cells. So that's now a 4, 8 pair. That's putting 3 there and 3 there, which I have pencil marked. Oh, because I got that one of those was a 3 from the row. Now, this is placing 7 somewhere here. Okay, I don't know the answer to that. So it's not, I was rushing forward a bit, that's all. Let's take it nice and handy now. 8 must be in one of those cells just by Sudoku. Now, let's think again. If that was 8, then we get this problem, don't we? We get a 9 there, which pushes 3 there, and that pushes 6 here. Which makes this a 2. Now, what was it that went wrong with this? Something did. If we have an 8 here, that requires that to be a 9. You get 3 in those positions. Well, if that's an 8, you get 1, 2, 4, 8 along that row, which places 8s here. And that is impossible. Right, there's a 4-8 pair there, so that can't be an 8. It's that simple. So this is now an 8. There we go. 4, 2, 1. That puts 8s in those positions. Well, indexing into row 1, row 2, row 4. Not into those positions. Let's tidy up the pencil marks. That 8 has made this a 2. And that's what I missed earlier. Okay, 4, 2, 4, 8. Let's get the indexing right. This is placing 3s there and there. This is placing a 9 there. That's fine because that allows 6s to go there and there, which is what that 2 and 4 are placing. Perfect. This is now not a 2, and in the box it's not an 8, it's a 1. That's putting a 7 there, and I think all our indexing is done, unless I missed one. And there is every possibility today. We've got 8 there, a 5-9 pair down here. That's a 7. I'm hoping Sudoku finishes the puzzle now because it's beaten me up a bit, to be honest, through my own foolish inadequacies. I have a lot of foolish inadequacies, and you get to share them with me more often than you want to. So I can place a naked 1 there. That's where 4 goes in the row. That's a 7. 7 in this box is there. This is a 2-9 pair, not yet resolved. That's 2 in row 3. Then I've got a 5-9 pair, which have a 6-4 pair above them. That's 1 or 5. Now, let's look at this row. Not so good. I suppose 2 must be in one of those cells. Okay, 2 in the... Yeah, that's useful to know. Oh, I should just place 2 in the middle box. That's how we do that. 6, 7, 8, 2, 4. How about this row? No, no good. No good, Mark. 8, 5, 6, 1. 3 is in one of those cells. 4 is in one of these 2. And I still don't know which one. That's 5. 2 in the final column is easy to place by Sudoku. Honestly, the outrage of asking me to try and solve Sudoku in my Sudoku puzzle. But first of all, trying to confuse me with a whole bunch of indexing and black dot constraints that I don't recognize. Yeah, it's mean, but I actually enjoy it. In a perverse and masochistic way, no doubt. Now, 2 there, 2 there. One of these is a 2. I'm not getting this done with any kind of alacrity. There's a 3 in one of those cells and a 3 in one of those. 6 is in one of those 2. I probably have missed some bit of indexing, haven't I? Oh, that would be horrible if I have to research all of that. I'm going to fight against doing that for as long as I can. 4, 6, 1 now. 5, 7, 9, 2, 8. Is this naked? 8, 5, 7, 6, 1, 2, 4. Yes, it is, because there's a 5-9 pair in the corners. So that can't be 5 or 9 and must be a 3. So that's not a 3. We get 3 here. 2. Now let's use this 5-9 pair again because it's surprising and probably helpful. I think it makes this a naked single. 5, 9, 2, 4, 3, 8, 7, 6. That's a 1. Then we have 6, 7, and 8 to place in the row. So this is either 7 or 8. That is 6 or 7. Now I've got this down to 5 or 7. There is a 2 in one of these. Let's look in the column. No, 9, 4, 6, 3. No, the column's not being very helpful. So this row, we've got a 2 there. These are from 5, 8, and 9. That is 5 or 9. This could be any of those digits. This is 5 or 9. It's another 5, 9 pair. There's another one here. There's 5, 9 pairs popping up everywhere. 4, 8, 5, 9, 2. So this is 1 or 7. This is a naked 1 though. It sees 3, 6, and 7 in the row. Oh my goodness. There's some quite tricky bits of Sudoku to do in this. Not just we have to do them. They're not easy. Or they're sort of trivial in a mathematical way, but I'm finding them hard to come by. Now, this is another part of a 5, 9 pair. And the other of 5, 9 must be down here somewhere, because in this box, they're not 5, 9. One of 5, 9 is there. The other isn't there. So the other is here. And that forms a virtual 5, 9 pair and makes that one a 4. And that's quite useful. 2, 5, 9. Now I'm going to get all my 5, 9s disambiguated, which is just what we wanted to happen at about this point. We get a 9 there, 5, 9. That can't be 5 or 9 now. That can't be 9. That's a 6. I think we're finishing off 8. Got 2 and 9. We've got a 4 there. 3, 6, and 1 5, 9 pair to finish with. What a lovely puzzle. Oh, that took some head getting round, and I wasn't delighted by the error I made on this pair, thinking it had to either be a 1, 2 or a 4, 8 pair, which I got conditioned into by this row where those pairs had to appear. Very clever stuff though. Thanks, Blundell. I really enjoyed that. Thank you as always for watching, and hope to see you again soon on the channel. Bye for now.